Greetings everyone. Today we have this oscillator for review, which is designed for audio frequency only. Why? I'll explain a little later. It comes with a very detailed manual, a power cable and nothing else. They didn't even put any connection cable, so I had to get one from my stock. And that's why it is designed only for audio frequencies, although the application is 500 kHz. But it only delivers 500 on scene. On triangles and sawtooths, 100 kHz of clear signal. You can screw up 500, but the desired shape is only 100. But on meander, only 50 kHz. There's also ECG and noise. Power supply voltage is from 4 to 10 volts. The current consumption is 250 milliamperes. The maximum output voltage is 10 volts. The controls are simple and straightforward. Power connector, power button, waveform selection, cursor movement, increase frequency, decrease frequency, start, stop, DC offset, filter on, and mix level. Here is the output amplitude and the output jack. Now it's the same thing when it's on. Powering up, selecting the output signal. Move the cursor to adjust the frequency. Increase or decrease the frequency. Start up. And on this block I will show on the oscilloscope screen and immediately say about its disadvantage, in my opinion. First of all, it is not clear whether there is or is not a signal at the output. There is no indication, only a blinking cursor, which is not always noticed. You could make a separate LED. The second disadvantage. As long as there is a signal at the output, we can change absolutely nothing, neither frequency nor shape. We have to press stop every time, make our changes and press run again. And perhaps this is even more disadvantageous than the fact that it does not produce high frequency signals. But the manufacturer did not promise us anything like that. Let's start with a 1 kHz sinusoid and see what minimum and maximum voltages our generator produces. At the very minimum, there is more noise than useful signal. It is not the generator itself that is noisy, but various sources of noise near my workplace. I disconnected the power supply and nothing has changed in terms of noise. Let's try to connect the power back in. No miracle. What is it that's picking up noise? And it's the oscilloscope probe itself that's picking up the noise. Yeah, I also turned off the workstation lights. Good. I'm adding amplitudes up to the maximum value. And it's much better here. I'm getting a slice of the signal. And it's 19.2 volts peak to peak. That's what the description says. 10 volts plus, 10 volts minus. Now a little bit about beam shifting. When you adjust up or down, you get a kind of cut of the upper or lower sine wave. Same thing with a meander. And let's check the linearity of the signal. On 1 kHz, I'll put 10 volts from peak to peak. And I'll set the minimum frequency to 1 Hz. Peak to peak 9.68. 10 Hz. That's about the same. 100 Hz. A little less, so it can be difficult to check the amplitude frequency response of a sound. 5 kHz is 10 volts. 10 kHz is exactly 10 volts. 30 kHz is exactly 10 volts. It's basically fine. At higher frequencies, 100 kHz, 9.68, and 500 kHz max, 5.34 volts, which is half that. Let me remind you, the sine is 500 kHz, but apparently it concerns only the shape of the signal, not the uniformity in amplitude. Let's move on to meander. 10 Hz and from peak to peak 10 volts exactly. 100 Hz, the amplitude is the same, but these things appear on the signal. 1000 hertz. Ten kilohertz, everything's just fine. 20 kilohertz is great. 30 kilohertz, and you can see for yourself that the edges are smoothed out. If you turn on the filter, it gets even worse. Speaking of the filter, maybe you need it to filter out high-frequency interference. No, it's not. So it's kind of useless. I'm setting it to 10 volts again. The maximum advertised is 50 kilohertz. Basically, it looks like a meander, but if you're controlling a field effect transistor, this smooth opening and closing will cause additional heating of the MOSFET. 60. 70. At 70, the signal's kind of bifurcated. 100 kilohertz. 200, and the waveform doesn't look like rectangles at all. 500 kilohertz maximum. It doesn't look much like a meander. What do triangles look like at that frequency? More like a sine. The saw and back saw looks like a dull saw. It needs sharpening. But just a reminder, the application is for 100 kilohertz of pure signal. And yes, the triangles at that frequency look decent. The saw looks like a saw. Reverse saw has rounded teeth. 50 kilohertz, everything looks good here. Who needs an EKG? I don't know. Maybe someone does. So does the noise from the rectangles. Basically, what I'm saying is completely true. It's good for tuning amplifiers. Basically for testing some kind of switching power supply. 50 kilohertz, it's not a perfect signal, but it works. Let's see what's inside it. That's always interesting. And inside the device is this green circuit board, which is a little bit glued to the case. And there are some painfully familiar parts here. The 1602 screen, which is used everywhere in Arduinos. Let's take it off now. Yes, it's a regular 2-line screen with 16 characters. Next, 2 TL082 operational amplifiers. Some chip with a faded name, but in the early versions of a similar oscillator here was Atmega 48, if I'm not mistaken, in a DIP package. And most likely it's an Atmega 2, quartz, power stabilizer, and some kind of germ. It's all very simple. Cheap rustling buttons that make this sound when they're pressed. And the filter button is jammed. Put it in the case and summarize the results. Such a simple generator. Nothing special, but the thing is really useful if you are constantly repairing some audio equipment. It also has an interesting price. It costs about $12 to $15 at the time of shooting this video. The link to it will of course be in the description. Thanks for watching. Good luck to everyone.